All right, so let's look a little bit and dive a little bit into a demo. So SD-WAN has been a somewhat elusive creature. So let's see what functionality is available today at this point. And the first thing I want to quickly highlight again is the three components that we have in the solution. So on the one hand side, we have the edges, which are the on-prem components. We have the gateways that are cloud delivered at this point. They're highly distributed, highly available as well. And we basically run these as almost a stateless virtual appliance in a variety of facilities around the world. So at this point, we have a global presence, as Sanjay was mentioning. We're present in Asia Pac. We have Western Europe presence. We're pretty much covered in North America as well. And what I'm going to do during the demo is I'm first going to show you a quick insight into the visibility, and if the network is fully established, on what you can see with the network and how it sort of works from a high-level perspective. And then we're going to start stepping back one at a time. We're going to go into the configuration and see how did we get to this point of establishing all the policies. And then all the way at the tail end, we're going to actually activate a new device and bring that online in the network and do a few tests. And then as a final point, Kangwarn is going to step in, and we're going to actually run a specific application and see the dynamic multipath in action as well. So we're looking at our orchestrator at the moment. So this is that central controller that we're looking at. So this is the place where you do the management as well as the insight into the network and what's going on with the network. And of course, this is a multi-tenant portal, as I was mentioning earlier. This is fully REST-based as well. So everything that you see on here, everything that you can click on here is backed by a REST call in the background. So you can programmatically access all of those functions as well. If there is an existing single pane of glass system that you are prefer to use, then we can just tie in with a REST API call there as well. And the first thing that you will see here is we get a quick overview of all the branches that are spread out. And I should point out, we're going to look at our live office environment today. So this is our own production environment that is currently serving the office traffic. So what I can do is if I see all of those edges online, we can immediately see what the status is of those devices. We can immediately see which links are connected to those individual sites. So if we click further into that, the first thing that's going to pop up now is that we get an inventory of the links that are present. And this is where the dynamic multipath actually will kick in. Every time you plug in a link into the device, the first thing that will happen is we're going to do characterization of that link on how well it behaves in terms of quality, what kind of capacities are available, and we're also automatically figuring out which service provider that is actually on. So important to know that this is all measured in real time, and this is sort of the foundation where we make decisions on. And as you can see on the right-hand side, we're actually clicking live statistics. So if we click on one of those sites, then we're actually going to signal this from the orchestrator that, hey, somebody's looking at you, go into an accelerated reporting interval, and you can see live statistics clicking from that perspective. So as you navigate away from this, it's going to detect that, fall back to a 5-minute reporting interval later on. So if we hover over to the right-hand side, you can clearly see that we cover all the latency, packet loss, jitter characteristics, they're all covered. And then we can also measure all the capacities in real time as well.
So how do you measure capacity?
Yes, it's a good point. So when you plug in the link, there is an active measurement at first that is done, and that gives us a high ballpark number. Then we basically tag on to the traffic of the customers, and we're going to measure that traffic as well to see if there are any large variations. If there are small variations, then we'll make adjustments. If there are very large variations, then we're going to trigger a new active measurement. And all the latency and packet loss characteristics, they're effectively done by time-stamping every single packet that goes through the system.
So you timestamp the packets as you encapsulate them, and then you look at the timestamps as they get across,
right?
And you get real-time measurement of actual customer traffic.
Correct, correct.
That's cool.
Is that an element of IPsec, or are you doing additional encapsulation before the IPsec?
Well, it's an interesting question because, on the one hand side, if you send traffic towards the gateway, it can sort of be two types of traffic, right? You can have your VPN traffic, of course, IPsec encrypted, all covered, but then traffic that goes to Salesforce, that's likely already SSL encrypted. It's not really a need to burn additional crypto on it. So we do have mechanisms in place to detect these are applications that are going to the cloud and eventually get exposed completely, and we disable encryption on those applications as well.
No, but the question was, if you do timestamping,
right,
and there is no timestamp in IPsec. So where do you put it?
The IPsec is actually inside a proprietary protocol that we run between
Okay.
the
You're
edges.
so you're doing an additional encapsulation.
Yeah.
Yes.
So are there any MTU concerns or anything like that?
No, because we do a lot of reassembly and reordering at the gateway side as well. So there's an entire engine that takes care of reconstituting the original flow.
So you can provide 1500 MTU end to end.
Yes.
Thank you for asking my question in a better way.
Fixed.
Oh, that's cool.
Can you do over 1500 MTU?
Not at this point, I believe. Right?
No, only because the LAN side doesn't support it at this point. But if we enable jumbo frames on the LAN side, we could. Our transport layer is agnostic as to how big the packets are.
All right, so another way to look at all of these characteristics is look at the historical view of it. And this is very common, like if you find out that there's a provider that has having an outage, you want to look at, like, did they actually violate an SLA? So we can look at just the throughput of each of the individual links. So you can select one of those links and find out how much throughput is going over the individual ones. And it's somewhat hard to see at the moment, but the traffic is actually already split out over the two links. So they're all active at the moment. Another way to look at this is we can look at the jitter changing over time. So there's very little change on the jitter side, or we can actually look at the packet loss side. Yeah, go ahead.
So you can use this to nail the service provider when he doesn't honor the SLA.
Absolutely.
Yes.
Yes.
I didn't want to say it like that, but yes.
I can say it like that.
Someone said it. That's all that's important.
It's okay. It's okay. It's all good.
You might get a little excited about that. Yeah.
And
Yeah,
this,
so
this dashboard is based in your cloud?
correct.
Okay.
This is web
And it's-
accessible.
I didn't actually see it loaded up. I'm sorry, I was looking away. It's not using Java or Flash or like that, right? Just HTML5?
Everybody on top speed are responsible for the
orchestrator
part of this. Now, this is actually fairly lightweight. It's all HTML based. There are no plugins or.
Yes.
Well done.
It's the simple things in life.
So yes, to come back to the original point, so like you do get live insight into what these providers are doing, and you get to see, to come back for a second, like we basically have in our office like 2 DIA links. It's not what you could say that these are relatively inexpensive links, and you still see glitches on these links, right? So it's not at all uncommon. Right, so another way to look at this is by looking at our quality of experience page. And this is something that we do is we look at each of the individual links, and we're actually going to score these links on how they behave for a specific traffic type. And we can look at different traffic types. We can say, like, how does this work for voice traffic? How does it work for video and transactional? And what the scoring does, it will actually tell you if the link or the system in general is ready to carry voice traffic. And you see that the bare links, the AT&Ts and the Cogent links that we're using, on a routine basis, there are still glitches and outages that voice will get impacted when we route the traffic directly over them. So this is where the intelligent steering comes in, where we can make either a steering decision, like in this case, for example, where you see one of the links is exhibiting packet loss, the other one is not, so we can simply make a steering decision to steer that voice traffic to the other link. And important to know here is that the dynamic multipath can do that on a per packet basis. So this is not moving a session, we can move sessions midstream. So that's very important.
Prevent that from being the case? I mean, out-of-order delivery can be a significant problem in some applications.
No, not really, because we do reconstitute the original flow at the gateway sites.
Okay, so you guarantee in-order delivery
Correct.
at the
That's
sort of the
correct.
output end.
That's right.
Okay.
Are you doing any parity?
Is that it?
Are you doing any parity to ensure that? Any,
Error correction, you mean?
yeah, error correction.
Yeah, that's the next point. So let's find another of these timelines. So over here we see like one link exhibiting packet loss. At the same time, there is some minute packet loss on the other link. So at this point, we're going to dynamically enable forward error correction techniques. And this is done on a per application basis. So not every application can benefit from forward error correction, and you don't want to enable it all the time. So when we detect these outages and we detect them on multiple links at the same time, then we are going to enable these forward error correction techniques.
So you can actually send multiple copies of a voice packet to ensure that at least one gets across?
That is one option, yes. So we can replicate packets, but we can also be a little bit smarter to just do parity injection into the flows as well.
There's a question there.
So when you reconstitute, are you adding latency? How do you avoid adding latency while you're waiting for fragments to arrive?
Sure.
Yeah, so everything in the system happens at very fast intervals. So we probe every 100 milliseconds. Packets are timestamped. Our hold timers are set in the millisecond range, right? So we will only hold packets waiting for that duplicate to arrive. Say packet one's lost, we're only going to give some order of, say, half a one-way time difference to allow the second one to arrive before we move on, right? So we're very careful not to cause additional harm while doing error correction.
So the net result of this is like after we apply the VeloCloud service, like you should see a clean link, right? So your application should breeze through the network, even if the underlying network is actually not as great as you would hope it to be.
Do you support any sort of flow reporting? And I'm specifically thinking so that something that consuming those flow reports could tell which link or links were utilized in that flow.
Yes, it's a feature that we have in the pipeline. So I'll walk you through the visibility aspect a little bit more. There's a lot of information available, but we can perfectly imagine that there is more.
Yeah, historical is more what I'm thinking of, because you get that call and, hey, this thing didn't work well.
Correct.
You want to see where, what elements of this magical WAN were involved. Okay.
So moving on to the application side, so this is actually the flow information. So we do have a deep packet inspection engine that characterizes about 3,000 applications at the moment. And important here is like if you combine that deep packet information together with like all the intelligence that we put in there to know like voice traffic needs to go to the lowest latency link. If it's Salesforce traffic, then spread that out over multiple links. If it's a bulk file transfer application, and aggregate the capacity over all these links. So that intelligence is sitting in the background. It will also automatically plug in like what are the QoS settings that we need to do on this particular application, what queuing mechanism do we need there. So all of that complexity is essentially abstracted in the background. But you can see now all the applications that are running over the network. We can click on these applications and we get a breakdown of the top devices that are sending that application and the top destinations where that is actually going towards. So we can further zoom in and take a filter over. If we want to look at now all the devices on the network that are sending Windows Live traffic, then we can get a breakdown of all these devices. We can clear that filter again and just look at all the devices that are on the network. And interesting to see here is that we can just hover over one of these devices and find out what their MAC address is, where their IP address is, what their host name is, what OS they're running. So a lot of good information that is very useful on a daily basis as well to quickly identify where things are.
And you're using native IPsec encapsulation, right?
Yes. So we use.
So do you support multicast?
Not at this point, no.
Okay. Also, is this
would be so sad.
Roadmapped?
And is this basically layer 3 only, or can you do layer L2 bridging?
So we haven't really run into use cases where L2 would be beneficial at the moment. So we haven't really focused on that.
Okay.
But like if you can encapsulate L2 and L3, then of course like it just.
But you don't do that. We would need to do
There's
that
no
somewhere else, and
native
then you're
support for
providing
that.
L3 services.
Correct.
Okay.
Correct. So then the other quick thing that I want to show you is so we can look at all the destination, all the domain names that we're sending traffic to, so that you can get a quick feel of like where in the world are we moving traffic towards. So what I'm going to do now is I'm going to switch to a more controlled environment. So this was our office network that we're looking at. So I'm going to switch to a demo environment where we can start moving around some policies and introduce a couple of new devices. So again, similar routine. You see multiple devices on that map here as well. If we scroll down, you can see some of the devices are offline. So this could be just devices that are disconnected from the network or where both of the links are effectively down. And then you see on the bottom a couple of devices that we have provisioned, but they're not yet activated as well. So if we go into the configuration side of the house now, and one thing I should mention here is like the topology that we're going to be looking at is we have on the table there an existing branch device, so we have a small edge that is sitting out there. We have an existing branch with just a Cisco router that is unprotected. And then all the way at the end of it, we're going to activate a new branch in that entire topology as well. So the first thing that I want to quickly show you is that we do run a couple of services throughout the entire enterprise. So we can define cloud proxy services. Sanjay was mentioning this earlier, that we just did a press release to support to showcase that we do Zscaler and WebSense integration as well. And you can tie in these non-VeloCloud sites, right? So if there's an existing data center out there where there is very expensive equipment already that is supporting IPsec, then we can just build IPsec tunnels from the closest gateway into those devices. We can do redundant tunnels to make sure that the connection is reliable. So, but it doesn't have to be limited to an existing data center. So this could be Amazon VPCs. They could be just large branch offices where you don't want to deploy VeloCloud at this point. And everything that we do is effectively centered around the use of a profile. And a profile is going to define how a specific set of edges should behave on the larger enterprise network. So what's going to be added into that profile. So we have two or a couple of categories in there. We have some device settings, some business policy settings, and some firewall settings. And important here is that we try to abstract again a lot of the complexity in the background. So there's a lot of items that just work with smart defaults, and we just want to make sure that you can concentrate on setting business policies rather than tuning specific flows and finding out which TCP port a specific application runs onto. So we do address management as well. So in the profile, we can say like what is the CIDR block that we entitle to the enterprise, and then if a new site comes online, like which networks and how big should these networks be that we allocate automatically.
Can you integrate with the routing protocols that are already on the site?
Yes, so we will shortly be announcing OSPF support for integrating into LAN site protocols as well. Yes.
So right now it's static routing, sort of.
Yes, towards the LAN site we do static routing at this point, correct. But that's soon going to change. Another important aspect is the small service catalog that we have at the moment. So that is at this point limited to a lot of internal services. But again, as mentioned, we're going to expand that to external third-party services. So WebSense and Zscaler are the first ones. And then down the line, we're also going to include virtual services that you can immediately run on the branch device as well. So let's switch to the device setting for a moment, and again, very simple. We have some interface settings where you can say all the interfaces that are on there. Do they need to be access ports, which VLAN, so the normal routine over there. We can also define all the wireless networking elements in here as well, so that you define the correct network SSIDs. And on the VPN side, so this is very straightforward. So it's just an on or off button. So very little that you need to do. It's virtually no configuration from that perspective. Question?
So this wireless that you're setting up, where's that live?
It's right here.
On the device.
So the device actually has built-in AP. So we have AC and wireless.
Okay.
For small branches.
Mm-hmm. Yeah.
And we can, of course, work with partners as well. Like if you have a large building and we need to have multiple APs, then we'll work with partners to do that as well.
What about .1x or,
Yes, so let me just switch that. So you can go to the security, you can do WPA to enterprise.
Okay.
And switching back to the network service, so we can tie into a backend radio server that sits either in the cloud or at your enterprise DC that is reachable over the VPN.
Okay.
So on the VPN side, very straightforward, on or off. The only choices that we basically give you is like, do we want to allow access between the edges individually, or do we want to tie in an existing data center site? So I've already tied in one enterprise data center here. Adding a new one is also very straightforward. We can simply say, add in a new one. Let's plug in a quick sample. You can select the equipment that is at your data center site. So if there is already a Cisco ISR or iOS style router, we'll plug in the public IP address for that site. What's going to happen next is that we'll just generate configurations that you can immediately plug into the data center router. So make it very easy for you so that within a matter of 5 minutes you can actually get that tunnel established.
Wow.
If it's the other way around and you're looking at integrating an Amazon VPC, for example, that is generating already configurations, then we can actually go back, go into the advanced settings, plug in your pre-shared key as well. So that's also an option. Yes, go ahead.
So I think I missed something. So when you generated the config that you would need to dump into like an ISR
right.
for this, do you get very granular on the code versions and everything for the different?
I do believe we have a minimum requirement on the code, but we're effectively not doing anything special. We're doing basic VTI tunneling to the ISR, and then we just do static routing with an IPSLA on top of that.
Is the ASA one of your options?
Yes.
Yeah, so actually the ASA one, if you look at the example ASA config, there's actually tabs for different versions because they changed the command structure in 8.3.
Correct.
Nice.
So let me just delete that again. So the next thing is switching to the firewall at the moment. And again, the firewall is very straightforward. It's an application level firewall. And we basically ask you to just say which application gets blocked. So we're not going to work or worry anymore about which individual flow you want to block. So if it's Netflix traffic that sprays across multiple destinations and CDN providers, then the DPI engine is going to aggregate all of these flows, and you can set a top-level policy to block Netflix traffic. So let's maybe introduce a new rule if we want to look at an application. And then let's maybe do that Netflix traffic. This is the way you block that. So you can either block on an entire category of applications, or you can pick an individual application. Another important aspect is the business policy, and this is where we really have all the steering decisions. So I've basically plugged in 3 policies. So there is one policy that says, like, all the traffic from the guest VLAN, we're going to shape that down to about 8% of the upstream and the downstream bandwidth, so that you can protect that bandwidth. There's another policy that says, like, all the Gmail traffic, I really want to run that through an enterprise DC where I have a DLP solution and scrub that first before it leaves the enterprise edge. So you can just backhaul that traffic into the enterprise DC. And then there's one additional policy that is going to move all the port 80 traffic, so all the web traffic is just going to be redirected to WebSense in this case. All right, any other questions so far?
Are there any logging or alerting mechanisms for policy violations?
For policy violations. So we do have alerting mechanisms in place for VPN outages, link outages, but can you give me an example of a policy violation?
So you block, site X, right? And someone keeps trying to go to it. Basically, they're continuing to try to do something, and you want to have visibility into that, see who it is, find some accountability, or maybe just, maybe a machine gets compromised or something like that.
Right, yeah, so today you saw our choices on the firewall were allow and deny. Deny and log, which actually can generate events and create a log of people attempting to violate the firewall rules, is coming in the next release.
But it does currently, you said it does currently do like a logging mechanism?
Yeah, the backend support is already there. It's just exposing it to the UI.
Oh, okay. And is it just a simple syslog or?
Yes.
Okay.
You mentioned guest VLAN, and it prompted a whole different series of questions. So obviously you can assign different subnets to different VLANs on the client side. Can you treat them as totally isolated VRFs afterwards?
Yes, the guest VLAN is completely isolated from any of the production.
And I can have a PCI VLAN and a video monitoring VLAN and whatever else VLAN.
Yes.
And they would be end-to-end VRF'd and isolated across the whole infrastructure.
Yes.
Okay.
Yeah, PCI is a big deal in these kind of environments, yes.
For monitoring purposes, are you going to have an allow and log presented as well?
So that's the first that I've heard of that request, but that's easy enough to add.
Okay.
Yeah. Sometimes you want to log something because you think maybe it's there. You're not sure if you should go and block it just yet or whatever. Sometimes you want to just check and just confirm.
You want to see if it's happening.
Right. It also provides.
So one thing we do have is, with the application visibility and all I the visibility in the system, you can see what's happening, what's being used. You can see what the most egregious offenders are. So it is easy to see.
I mean, I think the use case I could think of for that was maybe tying it into an existing analytics system, right, that you already have.
Correct. Yeah, but as you can probably guess, so the visibility items that we expose at the moment is based on like a whole slew of analytics that is in the background. It is sort of like the first tip of the iceberg effect.
Right. Excellent.
You guys have have you published any white papers that detail kind of how you're doing some of that? Yeah.
The analytics collection? Or?
Yeah.
That would fall under the secret sauce category, I would believe. Yes. No, so we don't publish anything in that. Yes.
We haven't published any white paper.
Okay. Okay.
Okay. Is documentation publicly available?
It's not publicly available. It's actually embedded in the UI. So there is a help button on the top here, and all the documentation is there. So we don't like to print documentation and send that out. Yes.
It's more just in terms of like if I'm looking at, I'm not a current customer, but I want to go through some of the documentation. Can I get access to that?
I'm sure our sales team would be able to accommodate that for you. Yes.
I'd be happy to accommodate that request.
So with the non-VeloCloud sites where we're setting up a VPN,
Right.
So they're VPNs terminating on a gateway that you specify.
Yeah, so there's two options. So we can either let it auto-populate and like find the best gateway for that data center. And for data center cases, we try to pick gateways that are as close as possible to the data center. So that is maximal protection all the way up to the data center. But we can move them around. If there is a very specific reason, then we can actually nominate a specific gateway.
And and I guess the downside of that is once you leave your gateway and head over IPsec tunnel back to that, we've lost all the cool source that was happening in the cloud overlay that you created, and we're now just back to chuck it across a link and hope, as you would have done if you hadn't had this solution, right?
That is,
for that last hop.
Yes, that is correct. But like the assumption here is that like once you're in the data center, that the connectivity is well established, that there is very little problems with that. If there are problems, then our data center edge device can actually sit in the data center and act as a gateway there as well.
Okay, thank you.
Right, so I'm going to switch quickly and speed up a little bit on activating a new device. I'll power in a new device for a moment. Let's get that going. Again, the links that we're going to be plugging in into the background, we don't really care how you plug in these links. So as long as they're internet ports, we'll plug them in. The system is automatically going to discover which link is plugged in where.
So if I'm shipping my box out to, a store where there's no technical people, to be honest, as long as they can fit the cable in there somewhere, it'll figure out what's going on.
Cable goes in color Jack X, yes, absolutely.
And it figures out the provider?
It figures out the provider as well, yes. So we do a reverse lookup on the IP address to figure out the provider. We geolocate them automatically as well. So like if we have multiple links, we're going to do a geolocation between those two links as well. And we're automatically going to place it on the map as well.
What's the process for like a private line circuit for the initial zero configuration?
Yeah, so that's a very good point. So private lines, there is of course like some element of configuration that you need to do, but we can supply that configuration part through the VCO. So as long as there is contact to the orchestrator and we can move some of the configuration in there, then if there is an additional private line circuit, then we can move that configuration into the
You plug it into the internet, let it download the configuration
Correct.
of the private line, and then
and then you
Okay, so like an LTE connection on a private line or whatever, use the LTE connection, pull down your config for your private line, then
exactly.
So on your provider discovery and geolocation, have you had any issues? I'm just curious if you had any issues with that, or false positive, or inaccurate mapping, because you think you're in South America and you're actually in Canada. I guess that could cause some problems, right? If you're trying to connect to a cloud.
Yeah, there are cases where ISPs will have blocks of addresses and then they'll spray them around. So there is a manual override if it's wrong. We see probably 1 out of 20 cases where that's wrong, just a sample that we've collected so far.
I guess the main point is if you drop me on the map in Japan, I can go and move it down to Melbourne
it's
or whatever.
override.
So you still need to do some pre-configuration if they're using things like PPPoE with authentication and that kind of stuff.
Yes, in that case you would have to push that out as well. Yes, and there is a very small UI on there. So if those cases happen, then we're actually during the activation going to get prompted to enter those credentials.
Okay, but we can pre-configure that before we ship it out.
Yes. So granted that there is an open link to the internet towards the orchestrator, we can push other configuration down. Yes.
No, he said pre-configure before sending it out.
No, that's.
Yeah, so if you have no technical staff where you're shipping it, and they have a VDSL circuit that's using PPPoE authentication, and I need to put that authentication on the box before I send it.
Yeah, so that's more a logistics problem. So like we can perfectly ship them to the headquarters. You could pre-configure and pre-activate them and ship them on. So that's of course an option.
I'd like to give you a config and then you ship it, and I never actually see the box.
Yes.
Yes.
Yeah. That'd be cool.
Yeah, the VCO will see the original link, and as it ages out, it'll just disappear from the interface. So if you stage it at a central location, it will show that link, and then a week later, it'll just disappear. That was just a temporary.
So let's bring up a new branch online for a moment. So I'm in the configuration dialog for a new branch. So it's very straightforward actually to do this. Hold on. So okay, not working. So I'll give it a name, and this is where we actually select that profile, right? So there's a couple of options. The network field A profile is the one that we were just looking at. And once I select that profile, then if we bring the new edge online, it's going to inherit all these policies of that master profile. For the cases where IP address management kicks in, it's going to fill those blanks in and basically make that new site come online with all the right settings.
You've got default profiles?
Yes, we do. We have a default profile for sort of like an internet-only branch where you want to have like every single site cookie cutter with the same addressing. Of course, no VPN in that case, and we have a more VPN enterprise style addressing mechanism. Yes. So I'll plug in my contacts over here. We'll hit create. So that's pretty much the extent of the involvement to create a new branch. So what's going to happen now is we're going to generate an activation key. And this activation key is actually going to bind the physical device to the policies and to the correct enterprise in a very late fashion, and then bring out all these policies and activate them on the system. So the only thing left to do at this point, or let me just scroll down. So we're asking about geolocation. So this is where you would do the overrides. Okay. So we can send out an activation email that automatically goes out to my email address. Send that activation email out. And before I continue, I want to just quickly go over the hardware specs. So I'll hand a couple of devices around, but we effectively have built-in Wi-Fi, as I was mentioning earlier. We have 4 LAN ports on these devices, 2 WAN ports, and an extra SFP port for the WAN. We have 4 USB ports that you can plug in LTE modems as well. So these are very solid solutions. So we see a lot of cases where people want to quickly spin up new branches. So they basically take 2 providers, 2 LTE modems, plug them in the site, put the device on-prem, spin up the Wi-Fi, you're in business that day. Very straightforward. And then of course this is based on an Intel platform, so this is VT capable and virtualization capable. There we go.
If I put one of these things out of a branch, and that branch is just something small with a DHCP provider.
Like the,
this thing calls home into the orchestrator.
Correct, yes.
Can I do inbound VPNs for management to this without knowing anything about that branch service provider?
Inbound VPN. So we do have, and I'll touch up on that in a second, we are able to do port forwarding rules and one-to-one net translation rules. So if there is a VPN system behind the device, then yes, you could do it. Yes.
Okay. But not directly to this?
There's actually no direct management on the device itself because everything is run through the cloud orchestrator. So, but you will get full visibility and you can run diagnostic tests from the orchestrator.
Gotcha.
Yes. All right, so let me switch to my email at the moment. So I should have received an email here with the activation code. And what we're doing here is we're simply going to give you 3 instructions for that person that's going to install it. Take it out of the box, plug in the power, plug in the cables in any jack that you see that is marked internet. And then we're going to request you to connect to a temporary SSID that we spin up. And this is the SSID that you see here. So it starts VeloCloud and then the last 3 digits of the serial number of the device. We'll connect to that.
So this part has to be done by somebody
on-site,
local on-site?
Yes, correct.
Okay.
And then we basically click on the activation link. Once we click on the activation link, so what's going to happen now is that the device is going to reach out to the orchestrator. It's going to do that late binding to the correct enterprise, figure out which policy and profile is associated to, pull all these policies down, and activate the network now. So you see, it pushed down some policies. It says like you have new networks live now. The tech field A networks are online and these are broadcasting at the moment. So you see that the LEDs actually turned red for a moment when we applied those policies. We're going to go into an amber LED now when we characterize the links in real time, and now we turn to green where we say like system is live. So that's the time it takes.
To get this straight, you ship it to site, you plug it in, it shows up in the system, you apply a profile, it sends an email to somebody.
Sure.
Somebody on site then joins the temporary wireless.
Correct.
Clicks the link in the email.
Yes.
How did they get the email?
Once you connect to that temporarily wireless, there is already internet access, but not to the service.
And it could be something like this as well.
Don't spoil my argument.
Sorry.
So yes, so if you don't have that email yet, just connecting to the device.
If they come up on that temporary Wi-Fi, they can get it. They can get their mail from the internet.
Correct.
All right. So that's really what I'm driving at is they have a way to get it.
As long as they can access their email without already being on the corporate.
Yeah,
network.
exactly.
Yes.
Is there a way around this?
This knows how do you do that?
Yeah. I mean, is there a way around doing this part locally? Because I see that being a stumbling block when you're talking about a bunch of retail locations that have like zero technical. It's one thing to talk somebody on the phone through, hey, plug this into the blue hole, right? Mm-hmm. But then, hey, go get email, click on this thing. I don't know.
Pre-configuration.
I see that
and
being a bit of a stumbling block.
We can pre-activate.
You can pre-configure that. Okay.
Yeah, I think that was the question asked earlier, whether you can do it in the corporate office and send it down. So it's all activated and ready.
Okay. So, but if you wanted to do that activation ahead of time, you would need to get it shipped to your corporate location, prep it, and then ship it out.
All I want to know is what serial number got shipped there, and as an administrator, I want to be able to say, yeah, that one, it's on.
Right, and some other similar solutions do that, right? It's just, you base it on PO even, right?
Right, I'm not understanding why someone on site has to do that last bit. I'm missing a link.
Because we don't want to keep track of the serial numbers effectively. So, like, we want to be able to ship out devices without having to know that. So. It also is very effective because, like, if, for example, one of the device fails, you need to RMA that device. It's just a matter of reactivating the new device because the configuration lives in the cloud. So there's nothing really locally persistent.
I get that bit. I'm just thinking from a network admin perspective. I know that a replacement device has been shipped to site. It gets plugged in, and I want to be able to go, yep, activate it. Not, hey, can someone on site please get on this Wi-Fi thing and. I understand why you have it local. I'm just saying having it the other way too might be, from an administrative point of view.
We can perfectly pre-activate as mentioned, so that's not a problem.
So you stand it up at corporate, it learns the corporate internet connections, but those will disappear after it's been activated. You just ship it out, plug it in, it figures out now what provider it's connected to, sorts all that stuff out, already has policy, and you're done.
Yes, so if we look at this, there is a Tech Field Day wireless network now that we can jump onto. So let me just quickly check.
See, it's 5 gig only. Is that by policy or is that just by?
That's by policy,
design?
so you can set 2.4 or 5 gigs, yes. So maybe just as a reminder, it's Valentine's Day, so it's coming up. So if we switch back to the orchestrator at the moment, so like if we go back now to the monitoring side, we click on that edge, we click on that new device that we have provisioned. So immediately you see like these are the providers that are plugged in. It's plugged in into that port. These are the capacities, and it's still measuring the bottom one at the moment. Oh no, it's measured, but it's no traffic on there. So you see that both of the links are effectively 10 meg links at this point. So at this moment, we're measuring packet loss, latency, all of that is already working. VPN connectivity is pushed down already at this point. And quickly show you that. So we have a new branch that is activated on the table now. There's another branch that is already pre-activated. So if we want to ping a small device, I've got a Raspberry Pi that's sitting up there that is just a dumb node. If we want to ping that now, it's actually flashing, so you can see visually that it's working. Same thing we can do for the data center side. So we have a quick web server that is sitting in the data center, and we can access that as well. Not very sexy to look at, but the key thing to drive home here is that the packet flow now goes from the edge over a VPN, over a redundant bundle of links into the gateway where that flow is reconstituted and handed off through a backend IPsec channel into the data center side. So all of that with sort of like zero engagement on the branch side. All right, so a couple of other items that I want to quickly touch upon. So we remember we had this WebSense item in there. So if we're going to go to a Yahoo website, and I basically blocked all the sports categories in there. If we click on sports, now that traffic is actually being punted to WebSense, and we see the blocking action from WebSense kicking in now.
So go out to WebSense. WebSense comes back to the
No, it actually, so from the edge, it's going through a gateway in the cloud, so our gateway in the cloud. We'll hand it off to WebSense at that point, and WebSense pushes it out to the final destination. So it's service chain now. Another quick test that I want to show you, because we're all running out of time a little bit, is a speed test. We want to see the effects of aggregation, right? So we mentioned like we've got these two 10 meg links. Ideally, if we want to run a test over the network, we want to take the benefit for bulk file transfer applications to capture the capacity of both of these links. So if we do a test, again, that traffic is going to go from the edge device towards the gateway, and you see it's well exceeding that 10 megs that we had initially. So very important aspect of the reliability as well.
Smart.
Yeah.
So Shri, am I out of time or?
You actually do real life link aggregation that actually works.
That's one way to put it, yes.
That is a key consideration.
Yes.
And that's packet based.
It's on a per packet basis, yes. And as you can see, this is very lightweight to install, right? So there's very little.
Simply.
I did show that.
I did average 16 on both.
Right.
So there is still a portion of the demo where we can go into the diagnostics as well as the multi-tenancy of the portal, but I think we're sort of like running behind on schedule. So if that's still of interest, then come and find me later on. I'll be happy to show you that. Great. Any more questions?
One question, just in more back to the policy, right? And so application definition and those types of things, like what type of granularity do you have? Is it just based off of ports, well-known applications, or are they already defined, or what does that look like?
Sure. So you actually have a lot of flexibility here. So if we go into the business policy for a moment, or let's do maybe a firewall rule. The way you define these applications could be either by source. You can define VLAN's IP address as ports there. You can do it by destination, where you get the same routine of controls that you can plug in. But you can obviously also do it by application, and we do support sub-application in there as well. So if I want to block Skype traffic, that is something that you can do. If you want to block Skype chat traffic in there, that's also something that you can do as well.
Can you crack SSL?
No, that should be a very bad thing if we could do that.
I mean, but can you do SSL intercept?
We do. We look at the SSL certs to classify applications. Yes. So we're not in the SSL.
I think that's a no.
That's a no.
No, we're not.
You're not doing the man in the middle type.
Okay.
We don't do SSL intercepts yet.
Go in.
Actually,
But you can open up the ability for something else too.
Oh yes, absolutely.
Okay.
Service chain. We're not doing intercept.
So you step into the negotiation process. You can figure out who the server actually is.
You can service chain in a WAN out device that does SSL exception.
Yeah, that makes sense.
Sure.
So to be clear, on your speed test example, your traffic, the gateway to the internet, even though these are internet circuits, we think, your gateway to the internet is through a VeloCloud gateway somewhere.
Sure.
Right, so that's the reason our aggregation works, is because it's going up to a central point that has big fat internet connectivity.
Yeah, so
and that's in the cloud somewhere.
That's in that magic cloud, yes.
Like that.
So yeah, absolutely.
So
I think
who's paying for that? Because it's a service, right? Who's paying for that bandwidth to the internets? So I'm paying for access to the internet from my site, but everything's getting tunneled to a gateway, and then the gateway connects back to the internet. Is that just part of the service?
That's a part of the
So
service.
that's why it's capacity based, because the more capacity I add, the more you have to provide through your gateways.
That is correct, yes.
Okay. I'm very slow, but I get there eventually.
lightning fast still.
Traffic needs to go through the gateway, right? So
Well, this was where I was going, was you have internet links that in theory could give you direct access out, but you'd lose that aggregation.
yes.
Yeah, it's the split VPN thing, right? Some goes tunneled, some just goes straight out.
Some goes private, some goes tunnel, some goes straight out. You
Right.
choose dynamically based on policy.
So in that, I can create a profile that says some stuff can go straight out to the internet.
Yes.
Other stuff, or in this case, everything gets pumped into the gateway and into our corporate.
So if you look at this policy over here, let me just switch over here to a profile.
As ever, you're ahead of us today. I like this.
So if we look at a business policy and we have this backhaul policy over here, so we can actually click on that and you can say like it's either going automatically out or pick a specific link.
Oh.
Yes. Cool. Yes. So you have that control as well, but by default everything automatically connects out.
Right, so you're choosing in that case either to push it to a gateway or one of the links or a specific link if you really want.
Yeah, so for example, social media, it's not something that we want to push to the gateway, like if that glitches for a moment. Not really any harm. So by default, it's going to go out to the internet directly, but of course you can change it.